Okay, hi, welcome. This is AP Physics review for motion in 2 dimensions. This is a really quick review, so I'm going to try to make it as quick as possible. Hopefully you guys understand. If you have any questions, please comment down below. Okay, so these are our rules. For the horizontal in the x direction, as in like this, because the horizon falls like this, in this direction, there are no forces pulling down, pushing down, or anything. No forces. We also have no acceleration, which means our acceleration would be 0 meters per second squared for any problem, because in the horizontal x direction, we have no acceleration. So acceleration is automatically a given. The object moves at a constant velocity, which means that v naught and final velocity are the same because it's moving at a constant velocity. So its velocity or speed does not change. And at the top of its trajectory, all motion is horizontal. So at its maximum point, it's moving horizontally. All right? And then as for our vertical y direction, the only force acting upon it is gravity. And we know gravity, as it is falling down or being pushed up with no air resistance, which is what we'll be mainly focusing on, is no air resistance. The force of gravity, its acceleration is 9.8 meters per second. Here it is. And it's always that. Always. So acceleration is automatically a given. The same way it's a given over here, which is 0. Over here, it's 9.8 in the y direction. Okay? It has no air resistance, which is why this applies. All right. And the object accelerates in the y direction. At the top of the trajectory, v naught for the y direction is 0 meters per second, which means an object, when it is being dropped or is falling down, always starts from rest. That is another given. And this is our v naught for the y. Right? Equals 0 meters per second. Now we're going to apply this to this problem we have down here. All right, example 1a. A marble is rolling on a table with an initial velocity of 5 meters per second. Then it rolls off the 3-meter high table. How much time does it take the marble to hit the floor? All right, let's highlight the key points. It has an initial velocity of 5 meters per second. All right. And the marble rolls off the 3-meter high table. How much time, so we're solving for time, will it take the marble to hit the floor? All right. Now, we can start this problem by drawing a picture what we are solving for. So, the marble is rolling off the table. So it's about to roll down. The table is 3 meters high. And it's going at an initial velocity of 5 meters per second. And it's asking for the time it takes for it to hit the floor. All right, let's make a table. This table will help you in most cases during any test or activity you may be doing when it comes to motion or projectile motion in 2 dimensions. All right, so we have our x and our y direction. And then we have delta x and delta y, which is our displacement in both the horizontal and the vertical direction. We have v naught, we have the final velocity, and then we have acceleration, and then we have time, which in our cases, time for both the x and the y are the same. Why? Because both will either clash at the same time or both will end at the same time. All right? So, our givens. We always begin with our givens because we know them. Based off the chart we did before in the beginning of this video, we know our givens are 0 meters per second squared for the acceleration in the horizontal direction because there is no acceleration as it moves in the x direction. Right. Then we know the acceleration in the y direction is 9.8 and it will always be that. So 9.8 meters per second squared. It's negative because it's going down, right? V naught in the y direction is 0 meters per second because the marble is rolling off the table. It's starting from rest, right? And then we have both initial velocity for the x direction, which is also the same as the final velocity because it is rolling off at a constant velocity. All right, so we have most of our givens. We are looking for time. In this case, our best equation would be the delta x equals v naught t plus 1/2 at squared. All right, one thing to note is that the x and the y are completely independent of each other. So you cannot mix two things from both sides of the table. You have to choose one side. If you choose y, you have to use that y. If you choose x, you have to use the x's. You cannot combine both and get an equation or solve for an equation because that's just not possible. Two completely separate things are happening at the same time. They just happen to be colliding into one. But you can't put them in together. So the equation we'll be using to find time is, I also forgot that it rolls off the 3 meter high table. In this case, since it's 3 meters high, we can see that it's vertical and it's rolling off, so it's -3 meters. All right, so we can change our x's in this case to delta y equals v naught y t plus 1/2 at squared. This one will cancel out because our v naught is 0 meters per second, and 0 times anything is 0. So that cancels out. So we're left with -3 equals 1/2 acceleration, which is -9.8 times t squared. And we're trying to solve for time. So this is what will give us time in the end. All right? So in reality, we can make it t equals delta y times 2 over acceleration. All right, so then it would be -3 times 2 divided by -9.8, which would then give us a time of 0.782 seconds rounded to the thousandths place using a calculator. And that is our answer. And that is how you solve for time using what we know. Our constants are givens and based off what we were told. We only solved for time. There's many more variables that you can solve for, but now this time goes in for both x and y. So now your graph is filling up a little more as time goes on. So then next question would be find delta x and so on. But that's it for today. Thank you guys. If you have any questions, please comment down below. Bye.